Continuing on with our terrain generator cleanup. In this video, Lee is going to be tackling the GetHeight method.
Right. There's a couple of different things that I want to get in here. If I scroll down the GetHeight, don't worry, the magic numbers are going to be fixed shortly. Not in this video, but they're coming. What I do want to change, though, is the way sample map works. We're not going to touch sample map until the next video, but I'm going to make the changes in GetHeight that are going to be needed when we get to sample map. So, and I've already got all kinds of stuff broken anyway, so what's another couple lines of broken code? So we're going to be switching up from passing in a texture to passing the layer that we want it to run on, specifically the number representation of the layer. So we're going to cast it to an integer. And for our H1, we were relying on, or saying that H1 was our low frequency noise. So we're going to be calling on low frequency noise here. I'm going to copy this, and I'm going to paste it for each one of our sample points. See, the mouse does pick on the wrong line that I want it to sometimes. It does it on purpose. H2 is our mid-frequency noise. H3 is going to be our high-frequency noise. H4 is our very high-frequency noise, but it uses the same texture as our high-frequency noise. So we're going to have high-frequency noise both times. And then our H5 is our base layer. Now this is why I wanted to be able to do this. It's just easier to read this code and figure out what noise map we're sampling from, as opposed to just putting in 0, 1, 2, 3, 3. And so that would be like 1, 2, 3, 3, 0. You wouldn't really know what you were doing unless you went through the rest of the code to figure it out. So that's just a way to kind of make it code a little bit more readable, seeing as how I don't like putting comments in things. Now, the other thing that I had mentioned that I wanted to do inside of the TerrainGenerator way back in the intro was I wanted to refine the algorithm that we're using for determining the height. What I want to be able to do is have finer control over how gradual or how abrupt the changes from sea level into the higher altitudes or the lower altitudes under sea level. To do that, I need to be able to split up the way we're sampling. Instead of just taking all of our numbers, blending them with our base map, taking that and running it through our exponential or modified exponential curve to compress things, I want to be able to do it at two different steps. I want to be able to take our flattened layer, which is going to be everything applied with this exponential curve, and then I want to be able to take our final sample without the exponential curve applied, and then modify it such a way that 0.5, or the halfway between 0 and 1, works out to be sea level. And then I want to be able to control the ratio of the flattened land to the non-flattened version of the heights based on the overall distance above 0.5 that we end up with. So it sounds more complicated than it really is. So what I'm going to do is right here where we've got var height, I'm going to replace height with B4, because this is truly just another blend. When all is said and done, it looks just like all the other blends. But what I want to do is use another var. This one is going to be our flattened, or so flatten height. And this is going to equal our little exponential equation output. But instead of height, we're going to use B4 here. So it's the same thing that we're outputting to our final height multiplied by our height, but we're just going to keep it in its own variable for now. Once we've saved that output, we want to take the original output of B4. We're going to take that, we're going to subtract 0.5 from it, and that's a float. So what that is doing is B4, and all these equations are returning values of 0 to 1. So I know that 0.5 should be sea level, and everything above 0.5 should be a positive number above sea level, and everything below 0.5 should be negative. So by subtracting 0.5 from it, I know that if B4 is 0.5, after this it will be 0. If B4 if B4, not B4, if B4 is 1, after this equation, it becomes 0.5. And if B4 was 0, it becomes negative 0.5. Now, the thing is, with our altitudes, we wanted it to go from negative 1 to positive 1. So I have to take that and multiply the whole thing by 2. This will ensure that whatever value I get is going to be in the range of negative 1 to positive 1. Now, we also said that we would like our terrain that is below sea level to be half the height of the land above it. So we can do another conditional that says if B4 is less than 0, then we're going to take B4 and then we're going to divide it by 2. So it's going to be divided by 2, and that'll be our B4. If it's positive, so now what we end up with is a range that goes from negative 5 to positive 1. And we need to be able to blend our flattened height with this new modified B4. To do this, we're going to define height at this point, and we're going to set it equal to our utils.lerp, because again, this is going to be something that's going to be called from inside of a thread eventually, and we want to be able to make sure that what we're doing is definitely going to be thread safe and not give us a hard time. We're going to lerp between our flattened height and the value that we've modified for B4. So B4 is the value that's been modified to compensate for sea level, but we haven't applied that exponential S-curve to it. And then what we're going to do here is we're going to weight this based on the absolute value of B4. And because the absolute value is going to be set to be a positive number regardless, it's going to go from 0.5 to 1 depending on how far away we are from 0. So the greater that we are away from 0, the closer we're going to be to B4. So what will end up happening is if B4 is at its max value of 1, it's going to be completely weighted to B4. But as we approach 0, we're going to get closer to our flattened height. Now, we can also multiply this by a bias value. Which will allow us to adjust how abrupt or gradual that change is going to be. We don't have a bias value, so I need to create one. Again, we're going to have a magic number for the moment. And right now, I'm going to set that to be 2. So what ends up happening is we're going to blend from our flattened value to our full value at twice the rate that we normally would. So what the larger your bias value is, the shorter that you're going to have your beaches. The width of your beaches are going to be much narrower than they normally would, because we're going to be blending out our flattened version of our terrain much quicker. And we also want to take that whole thing, and do I still need one more? Nope, I need, that should be all the brackets I need, but I do need to multiply that by our max height. And it compressed all my multiplications again. I hate that. And now that I've implemented the new algorithm, I don't need those last bits. So this should accomplish what we need. And again, after we deal with the config sys, or the config class, which is going to handle our config ini file, we can come back and get rid of all these magic numbers.
Okay. So is that everything you wanted to do there?
Let's build it, make sure I don't get any errors that are up there. I know I'm going to get these because this sample map's not going to be happy with it. But it looks like the errors that I have are the errors I expect. Next video, when we come back, we're going to apply the changes to sample map.
All right, fantastic. Well, with that, that's going to conclude this video. Thanks a lot.